previous video I simply gave you the method and how it flows, but now here we'd like to do an example and then see how we can do it in practice. Okay. We would like to find the root for f of x, given as just a minute, x cubed plus, oh, this is minus 9x plus 1 equals to 0. I would like to find the root between 2 and 4. Okay, so for the root between x equals to 2 and x equals to 4 by the bisection method for f of x equals to 0, where f of x equals to x to the power 3 minus 9x plus 1. So I set out this table here, and we would like to summarize all our steps in this table here. So we would like to have this table as follows. So here we have n, where n is going to stand for the iteration count, the iteration number. Then here our a, okay, this is the interval a, b, okay, so we shall call that an and bn, right? And then this we shall call it bn, and then we shall compute for f of an, we shall compute for f of bn, right? Then we shall compute xn, which you say that if we have found out that the root lies between an and bn, then we can find or approximate that root by taking 1/2 of an plus bn. And then we shall also compute f of xn, and then we shall find f of an times f of xn, just to know whether the root lies between an and bn. If it does not, then it will lie in the other interval. Okay, let us do this. If we have an, and then we computed xn, and then we computed bn, okay, if the root lies between an and bn, then the product of f of an and f of xn should be less than 0. If it is not, then the root will lie between xn and bn. Okay, so we shall do that, and then we shall compute the error here, and then we shall do the update. Remember, we said that depending on where we have found out the root is going to lie, then of course we have to update our an plus 1, and we also have to date our bn plus 1. Okay, for this case, since we have this, we shall start a naught, of course, is 2, and then b naught, that is our starting interval. Now we first have to be sure that actually the root lies between this interval. And how do we do that? We check of f of a naught, which is the same as saying f of 2, okay, and then we shall also check of f of b naught, which is equal to f of 4. Okay, then if the product f of a naught, f of b naught is less than 0, i.e. they have different signs, then we know that the root lies between here. All right, okay, so we start. Let's start off. So n is 0, a naught is 2, b naught is 4. F of an is f of 2. Please check that these are correct. I just computed them before we started because I make so many mistakes, so I just wanted to do this beforehand before I compute this. And then f of bn, that is f of 4, okay, computed it to be 29. And then of course now we can see that f of an and f of bn are of different signs. This is negative while this is positive. That means we are sure that the root lies between 2 and 4, and therefore we compute our xn, which is 1/2 of 2 plus 4. So 2 plus 4 is 6, and 1/2 of that is 3. And then we find f of 3. Okay, we substitute 3 in our equation here, f of x, and then we compute it. The answer is 1. And then now we check f of xn and f of an. Okay, now that we have computed xn here, so we check f of an and f of xn, the sign. So f of an was a negative, and f of xn is a positive. That means they are of different sign. Okay, and their product is okay, the sign, f of that and that, the sign is a negative. Okay, so of course we can't compute here the error. This is just the first approximation. Okay, the difference between